This is lesson 9.6, more transformations. Our objectives for today are to be able to explain the changes made to a graph by transformations, label and graph a function, look at a graph and write the equation, and given a set of transformations, write the equation. So to start, I want to warm up to review a key concept that we will be working with today, and that's absolute value. You hopefully have heard of this before. The absolute value of a number is its distance from the number line. So this means that negative numbers are turned positive when you calculate their absolute value because it's the distance they are from 0, right? So like 3, if you looked at a number line, you have 0, 1, 2, 3, right? It's 3 spaces away from 0. Negative 4, right here, is 4 spaces away from 0. Absolute value is a distance, and distances are always positive, right? Does this make sense? Okay. Now, what about equations like this that are absolute value? So this one is interesting. You have x plus 2 equals 7. Okay, so this has a hint. This has two answers because there are two numbers in here that could make it equal 7, right? That's because absolute value equals 7 when either 7 or negative 7. So what we have to do is say x plus 2 could equal 7 or x plus 2 could equal negative 7, right? So we have two different cases to solve. So if x plus 2 equals 7, then it's 5. If x plus 2 equals negative 7, then it's negative 9. So 5 or negative 9. Same with this one. This absolute value, it could equal 4 or it could equal negative 4 because both 4 and negative 4 absolute value to make 4, right? So add 1 and we get 5. Add 1 and we get negative 3. Okay? So does that make sense? So you can see now that absolute value equations end up having two answers. They're actually really similar to x squared equations, to quadratics. I'm going to show you that. So I want to show you a demonstration now of this. So here we have just the basic y line y equals x. You've seen this before. It's just a straight line, y equals x, and you get all the points 1, 1, 2, 2, because y equals x, right? The y coordinate is equal to the x coordinate every time. All right, so what if I change this? I'm going to make this absolute value of x, and let's see what that looks like. Okay, so notice now it looks like a V. So on the right side here, from 0 up, we have the exact same line that was y equals x before, but now the left side has been flipped up. Instead of negative 1, we have negative 1, positive 1 now. So I'm going to type this in because just like x squared, we can write this in transformation form with a's, h's, and k's, and notice how they affect it. So look at this. A, look, it does the exact same thing. Reflects it upside down when it's negative, right side up when it's positive. It gets steeper. H moves it to the right when it's negative, to the left when it's positive. K moves it down when it's negative and up when it's positive. So it actually works exactly the same way as it did for our parabolas, right? If H is at negative 3 and K is at 2, our vertex is at positive 3, 2. And then if we set A here to 0.5, it's like we have a slope of 1/2 going from the vertex. We went up 1 and over 2, slope of 1/2. See that? So it actually works exactly the same, and then the graph looks like a V instead of a parabola. So that's pretty cool. Okay. So, in other words, we've learned about two types of equations. Now, x squared and absolute value of x, and they work exactly the same. Okay? So let's review from last time, right? If we were to describe the transformations. So the number out front is our stretch, right? So stretch by 4. The x goes left and right, but remember it goes opposite. So if we have a -5, it's right 5. The +8 means up 8, right? This is an x squared, so if we graph this, so right 5, up 8. And then stretch 4. So 1, 2, 3, 4, and over 1, and draw your parabola. Oh, it's a terrible parabola. Sorry, guys. All right. Negative out front means reflect over the x-axis. Right? And then this will mean left 6 and down 10. So if we go left 6 and down 10, that's where we're starting. And then negative, it's like a slope of -1, remember invisible 1. So down 1 over 1. And there we go. All right, so let's try one now with an absolute value. So all the transformations work exactly the same. This 1/2 is going to be like our slope, right? So in this case, since it's smaller than 1, we'll say shrink by 1/2, right 8, up 5. Okay? So in other words, the vertex, it's also called a vertex with this. So the vertex is at 8, 5. This time it actually is a slope because these are lines. It looks like a V, but it actually, right, it's a reflected line. So it is actually slope in this case. So 8, 5. So 8, 5, there's our vertex. And then a slope of 1/2. So up 1 over 2, up 1 over 2. So this time make it straight lines coming off. There we go. So they look like a V, right? Okay. Next one. So 9 out front. So stretch by 9. And then right 12. And then up 17, right? Let's count by 2s this time. So 2, 4, we'll put a 2 here. If you're going to count by something different, always label it. 2, 4, 6, 8, 10, 12, and then up 17. 2, 4, 6, 8, 10, 12, 14, 16, 18. So right about there. Okay, so stretch 9. So we're going up 9 and over 1. We're counting by 2s, remember that? So I'm counting by 2s, so it's like 2, 4, 6, 8 and a half. So that's 9 right there. And then over 1. So kind of go like half the distance here since we're counting by 2s on that. Oh, and make a V. I started making a parabola. Make a V, not a parabola. Okay. All right. So now let's try if we're given the shifts, can we write the function? So it's giving us the parent function. So we're using absolute value of x. Okay. So we want to shift it 8 units to the left and 2 units down. So 8 units left would be a +8 in with the x. 2 units down would be a -2 on the outside, right? So 8 left, 2 down. Next one, still using absolute value of x. Stretch by 2, reflect across the x-axis, up 12. So stretch 2 and reflect, that means it's got a -2 out front. There's no left or right, so we'll just leave the x by itself and then up 12, right? Stretch by 2, reflect across the x-axis, up 12. Next one, reflect across the x-axis, compressed by a factor of 1/4, down 5. So compressed, that's the same thing as shrink. So reflected, compressed by a fourth, down 5. Okay, makes sense? Reflect, compressed by a fourth, down 5. Oh, here's an easy one. Shift 9 units up. So up and down is the K that goes on the outside, 9 up. That's easy. All right, so now we're going to graph and list the transformations first. All right, so we're looking at a squared graph, so this is going to be a parabola. So what do we got? We've got nothing out front. Remember, it's actually an invisible 1, right? So we have left 2, down 4. So over on our graph, we'll go left 2 and down 1, 2, 3, 4. There's our vertex. It says label the points, right? So we have to go left 2, down 4. It says label 5 points. Don't worry about that. The other teacher did that. You only need to have 3. I want you to have the vertex and then use the slope. So up 1 over 1, up 1 over 1. So just show me those 3 points. That's all I need you to show me, okay? The vertex and then using the slope. Remember, this is like an invisible 1, so it's a slope of 1, up 1 over 1. Next one. So this time we have an absolute value, so it'll look like a V. So invisible slope of 1, and we're going left 1, down 4. So left 1, down 4. Left 1, down 4. Invisible slope of 1, invisible 1 in front of that. Okay, so now you're going to make a straight line. Okay, it should go right through the boxes. Not bad for computer drawing. It's hard, you guys. All right, next one. So we got a squared graph. It's a parabola. So this is a stretch 2, a left 1, and a down 3. So let's go left 1, down 3, and then stretch 2. So it's like a slope of 2, up 2 over 1, up 2 over 1 the other way, right? These are symmetric. And then this time it's a parabola, so draw a parabola. Okay. Next one. So shrink by a half, and then right 6, down 4. So we're going to start right 6 and down 4. There we go. And then shrink by half, so the slope is like 1/2, up 1 over 2. Up 1 over 2. And then make our parabola. So remember that these are just sketches, so it's like you sketch it in, you can't, it's not totally accurate, right? It's just a sketch, okay? That's all we're going for. I want to see these 3 points, those should be correct, and it should look like a parabola, right? But it's just a sketch. Okay, next one. Now, what about if we see the graph, can we write the equation? So let's see, I'm going to look here. Where is this vertex at? This vertex is at 4, 3. And let's look at where the slope is, right? So where's the next points? Here and here. So we have to go down 1 over 1. So it's like a slope of -1. And this is a parabola, so it's going to be an x squared equation. So you have a -1 out front. We never write the 1. Remember, the x coordinate changes sign, and the y coordinate stays the same. So see, I put the vertex right here, and then I put the slope out front. Got it? Okay, next one. This time we have a absolute value equation. So here's the vertex. The vertex here is at 1, 2. And then what are we doing for our slope? So to get to the next point, we go up 1 over 1. So this is a slope of 1. So if it's a slope of 1, it's an invisible 1. We don't write it. X coordinate changes sign, y coordinate stays the same. Okay, so I put -1 plus 2, and then 1 is an invisible 1 on the outside. All right, last one. I have an absolute value again. So here I am, my vertex is at -1, 4. And then what's my slope here? So it looks like you go down 1 over 1. So a -1 slope. So a -1, but 1 is invisible, so just a negative. X coordinate changes sign, Y coordinate stays the same. All right, so now give this a try on your homework assignment. If you have trouble, be sure to email me or text me on Remind or hop on the Zoom office hours. Make sure you take a picture of this and send it in. Thanks, everybody.